Alright, we've got some imaginaries, so I think we'll just put these bunched together. So we're trying to figure out which one is equivalent to this. So I need a minus bi times a minus bi. If you are lazy and you just do square and square, first of all, that's not math. It doesn't work that way. This is what squared means, this times this. And so you don't simply get those two squared. It's a little bit more complicated than that, as we can see as some of the options are here. So I multiply, I get a squared minus abi minus abi plus bi squared. Now remember, I squared is equal to negative 1. These are both the same, so I have two of them. And so this is my answer, which is hanging out right about there. This one here, though we have parentheses, it's really just a subtraction problem. So I need to distribute that, which gives me this. I need to distribute this, which gives me this. And then I just combine like terms. So I have a positive 11 and a negative 5i, which gives me d. Alright, last but not least, we really need to do exponents before we do multiplication. So I have 6i here, but negative 2 cubed is negative 2 times negative 2 times negative 2, which is a negative 8. And I cubed is this. So I really have, what, negative 48 I to the fourth. I to the fourth is really 2i squared, and I squared is really a negative 1. So this gives me a positive 1. So my answer should be B. Alright, last little complex little dude here. I do need to multiply by the conjugate. The conjugate is the bottom with a different sign in the middle. It is just as simple as that. And then you just have to multiply like a crazy person. So we have a positive 36, a plus 12i, and a minus 12i, so those cancel. And I have a negative 4 times a negative 1. Remember, I squared is a negative 1. So on the bottom, we get 40. On the top, we get negative 48 minus 16i plus 6i and plus 2 times I squared, and I squared is a negative 1. So these little bad boys give me a negative 10i, and a negative 48 and a negative 2 gives me negative 50. So I split this up so I can look at my real versus my imaginary, which reduces to this and this. And hopefully we find it. Yay, we do.